We're looking at optimization problems. We did example number 1 already. So in this video, let's go over example 2 and 3. 2, it says find the absolute maximum and absolute minimum values of this function g of x, negative 9x plus 2. But this is just a linear function. You see, it's a y equals mx plus b. This is a linear function that is going down from left to right with a slope of negative 9. So this is a function that's going down from left to right. So if I graph this, at negative 2, where would that be? G of negative 2 is negative 9 times negative 2 plus 2. That is 18 plus 2, that's 20, right? So I'll have negative 20, negative 2, positive 20 plotted, and the next endpoint 5. G of 5 is, and this isn't my work yet, I'm just trying to do this. Negative 45 plus 2, that is negative 43. So somewhere down there. So as you can see, without really doing calculus, this linear function is going down from left to right. So the absolute maximum will be on the starting point, and the absolute minimum is going to be at the ending point. There's not going to be any critical value because the derivative is never going to be 0. But let's go ahead and do this using the method that I did on example number 1. So whenever you're finding absolute maximum or absolute minimum over a given interval, what you're going to have to first do is find the derivative. Okay, find g prime of x. G prime of x is negative 9. Because this is a linear function, derivative of negative 9 is negative 9x is just negative 9. So now you're thinking, when is this g prime of x, which is equal to negative 9, ever equal to 0? Can you have negative 9 to be equal to 0? No, right? So this just showed that there is no critical value. This function has no critical value. So what? We still have to check the endpoints. So now let's find g of negative 2 and g of 5. If you're wondering where did you get these numbers from, these are just the left endpoint and the right endpoint. You just have to find the function values by plugging these numbers into the g of x. That's positive 18 plus 2. That's 20. Hey, I did this. Didn't we do this, right? Negative 9 times 5 plus 2. That is negative 45 plus 2. So that is negative 43. So this one is bigger. 20 is bigger. So this must be absolute maximum. And because this is smaller, this is the absolute minimum in this interval. So let's fill in the blanks. Absolute maximum value is 20, and this happens at x equals negative 2. Absolute minimum is negative 43, and this happens at x equals 5. Okay, let's do one more. It's very similar types of problems. Oh, this could be a little bit challenging because h of x is not just a linear function. This is a rational function. All right, it says find the absolute maximum and the absolute minimum of the value of h of x equals x plus 16 times x to the negative first power. So guess what I just did? I rewrote rewrite h so that I can use the power rule to find h prime of x. I just rewrote it so that I can use the power rule. So if that is h of x, what is h prime of x? Let's find h prime of x. H prime of x is, derivative of x is 1. Now let's take the derivative of this. Multiply this negative 1 by the coefficient of 16. I get negative 16 but you need to go down 1 from this original exponent of -1, so that goes down to -2. If I rewrite this back in a fraction form, this will be 1 minus 16 over x squared. So now what I need to do to find the critical value, go ahead and write this down, to find critical values, set h prime of x equal to 0 and find where h prime is undefined. Because critical values happens when the derivative is 0 or when it is undefined. So let me go ahead and do setting it equal to 0 first, okay? So if I set 1 minus 16 over x squared equal to 0 and try to solve for x, I will get 1 equals 16 over x squared. I just added 16 over x squared to both sides. And let me go ahead and multiply both sides by x squared. If I do that, I will get x squared equals, cancel, 16. If I take square root of both sides, x comes out to be plus or minus 4. I'm going to circle this. I have two critical values from setting it equal that I got from setting it equal to 0. But how about where is it undefined? H prime of x, which is 1 minus 16 over x squared, is undefined when the bottom of the fraction is equal to 0, right? When that is equal to 0, then this derivative function is going to be undefined because we're not allowed to have 0 in the bottom of the fraction. Take square root of both sides, plus or minus, I mean this is plus or minus square root of 0, but that is just 0, right? Because 0 doesn't have a sign. So guess what? How many critical values did we just find? 1, 2, 3. We have 3 critical values to test. So let's take a look at the range, because the interval they gave us is from +4 to +20. So, you know what is unfortunate? Take a look at what we just got. 0, this is not in the interval, right? Because they said, they said, hey, we're just looking at the values in between +4 and 20. 0 is smaller than 4, so 0 is not in the interval. So we're not going to use it, so throw it out. We're going to throw out x equals 0. We're not going to look at it. It's not even in the interval. How about 4 and -4? 4 is in the interval. How do I know that? Because they use a square bracket. That means 4 is included. Okay, but we can tell that -4 is not in the interval. So we'll throw that out too. Okay, so we're only going to test 4 and the endpoints. Okay, so let's go ahead and plug in 4 and the endpoints. So first of all, what is h of 4? Hey, you know what? The endpoint and that only critical value that survived this check was 4. So I end up just doing the endpoints again, huh? So let's see who comes out to be bigger. I need to plug in 4 and 20 into the original function to compare the numbers. So first of all, 4 plus 16 over 4. That's easy. Wouldn't that just be 8? But I better double check because I don't want to make a mistake. All right, I typed this into my calculator. It came out to be 8. Next one, I plug in 20 this time. 20 over plus 16 over 20. Oh, that's not going to be a nice number. Let me go ahead and type this into my scientific calculator. When I typed this in, it gave me 104 divided by 5. And if I want to know the decimal of it, just because so that I can compare it, it comes out to be 20.8. Who is bigger? Compare these for me. Compare 8 and 20.8. 20.8 is bigger, so we're going to tell that our final answer, the absolute maximum value is 104/5 or 20.8, and this happens at when x is equal to 20. The absolute minimum value is 8. That was a smaller y value, and that happened at when x equals +4. So we looked at about 3 examples finding the absolute minimum and absolute maximum using the critical value. They were a little bit different, right? They were all different, but try the homework problems. If you see anything significantly different from these 3 that we did together, let me know. We can do another example. I'm going to stop this video because I was going for about 10 minutes. I will come back and do example 4 in another video.